Hello, 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 1, 2, 3, 4. Hello, hello, 1, 2, 3, 4. Hello, 5. Okay, you guys, you know the answer? This last two. What does he look like? I think it's one of the movie or series, right? What kind of occupation do you think he works at? Huh? Police? Manager? You think he's a manager? Like manager wear hoodies? Like who normally wears like dark hoodies? Rapper? Okay, that's a good answer. But I mean, do you think they will make a movie or series on rapper? I think it's possible. But yeah, singer. No, he's a hacker. So he's a hacker in this movie. You guys heard a series called Mr. Robot? I think this is the one. He also is in the Mr. Robot series as well. If you haven't watched it, I highly recommend. Like they actually all the hacking there is super realistic, right? Whatever they present in the series is actually quite real. Huh? Mr. Robot. It's not a movie, it's a TV series. Mr. Robot. You can just search on that, right? So now you see, right? He he's a person, right? But depends on the movie he's in. He can have different forms, right? On this movie, Bohemian Rhapsody, he's a singer. On James Bond, he's a villain, right? And on Mr. Robot, he's the hacker, Mr. Robot, not Roblox. Okay. So this is one example of polymorphism, right? Depends on the context, he can exhibit different forms, even though he's still him, right? But depending on the context, he would behave differently, right? But in the end of the day, he's still the same guy. Do you guys, I don't know, you guys still remember this game? You guys probably don't play it anymore. Among Us? Huh? Huh? Among Us? Yeah, it used to be very popular, right? Is also an example of polymorphism, right? What kind of forms does he have? You play as this character, right?
Yeah.
But what forms? Huh? Crewmate and imposter, right? So it depends on whether you are selected as a crewmate or an imposter, right? Then you would be a different guy, right? Different forms, right? It depends on the context, right? It depends on the rounds that in this round, you may become a crewmate. The other round, you become an imposter. Another example, I suppose, is you. You can also have many forms depending on the context, right? If you go to the school, you are a student, right? No, this one is saying you. It's pointing to you. It means you.
Pointing to us.
Yeah, pointing to you. Huh? Uncle Sam. Yeah. If you're at school, you are a student, right? If you go back home, you become what? You become a student? No, right? You become what? You will be a child, right? A family member, right? When you go back home. What if you go to work as a part-time? What do you become? Employee, part-time employee, right? So it depends on the location, depending on the context, right? Even though you are the same you can exhibit different forms, right? Now, do we agree, right? A single object, a single you, right, can have many forms depending on the context you are at, right? So in this context of OOP, when we talk about polymorphism, we refer to a single piece of code, the same looking code, but they may behave differently depending on the context you're using, depending on where you're using, depending on when you're using. We have three main types of polymorphism, ad hoc, subtype, and the parametric polymorphism. We will only talk about the first two. The last one is also important, but I will let you guys study yourself since we don't have enough time in this course, okay? Ad hoc polymorphism refers to that you can have a single method, right? A single name of the method that can refer into different methods in the same class, right? The same class can have the methods, multiple methods with the same name is what it means. For example, you can have a class for calculator, right? You can have three multiply methods, right? Same method names, but they behave differently, right? The first two accept integer as the input. Sorry, the first one accept integer as input. The second one accept double as an input. The last one accept float as an input, right? So their behavior is different depending on the input you provide. Okay, right? Have you seen this before? Have you seen this? Well, in Java, you can have multiple methods with the same name, right? As long as they can be differentiated by the input arguments. That's fine. What's another name that we have seen? We have a name for that too, right? That is not ad hoc polymorphism. Method overloading, right? You can overload the method with the same name, right? With different implementation as long as they have different input arguments, right? And we talk about what if they have the same input arguments, but different return type. Does it still work in Java? For example, in here you have multiply, taking both integer as input arguments, but return type is different. Does it work? Yeah, we already seen in method overloading when you cannot do that. Any question? Done. We're done with the first one. Easy, right? So now you only have the other one left. The other one is called subtype polymorphism, which is more interesting. You guys did the quiz in the morning, right? Well, except you. You should already know that whenever you create a subclass, right, that subclass object belongs to the superclass type. For example, if you have four classes here, right, shape, superclass, circle, square, triangle are the subclass of shape, right? Now you know that square is a shape, triangle is a shape, circle is a shape, right? But shape is not exactly square. It's not always square, right? Shape is not necessarily triangle, and so on and so forth. Okay, this one you understand, right? For subtype polymorphism, it means that since every subclass is a superclass type anyway, right? Then technically you should be able to use subclass object where the superclass is expected. Right? If you declare a variable to be the superclass type, then that variable should be able to hold the subclass object too. Make sense? Let's look at example. If I declare a variable shape S, right? If I put shape S equals to new shape, this one is normal, right? So S will hold the reference to shape object. You guys still remember the reference, right? Reference data type, right? S will hold the address that points into the shape object. This one is we already know how to do it using normal constructor. But you can also do this S equals new circle. When you do this, right, you create a new circle object first and assign S to point to circle object. Okay. Now you see, right, the left-hand side and the right-hand side are different classes, different types. S is type shape. On the right-hand side is the circle object, right? Technically, this shouldn't work, right? When you learn, right, you cannot assign int a equals to string, right? When you declare something, it has to be the same type, right? If you declare S as an int, you have to assign to the int, right? If you declare as an array, you have to assign to the array, right? But here is the exception. In here, right, the left-hand side is the shape object, the superclass object, right? So you would expect S to correspond to the superclass object, right? But by using subtype polymorphism, it's saying that you can use the subclass object instead, because subclass is a superclass, right? Circle is a shape, so that's why I can put the circle object to the shape variable, no problem. Make sense? Right? You expect S to be the superclass, right? And subtype polymorphism saying that the superclass can hold the reference to the subclass. Okay. So you can do that. Same thing you can do for triangle as well, right? You can assign S to point to a triangle object. Okay. So this is how it works, right? In practice, when you do S, if you declare S to be shape and you do S equals to new circle object, what happens is it changes the reference from S from shape into the circle object. It points to the circle object, right? When you do this, again, S equals to new triangle, it redirects the reference from circle into triangle, right? This is how the reference data type work. Okay. But this is also one way. The other way doesn't work. You cannot have a subclass type point into superclass object, because superclass is not a subclass, right? Shape is not a circle, so you cannot assign a shape object to a circle variable. This doesn't work. Make sense? Why? Why it doesn't work? Because if it works, right, then, for example, if the circle have the method called getArea, right? Then when you do this, right, you should be able to invoke getArea method on C, right? But the C actually holds the reference to shape object that doesn't have getArea method, right? So this will cause a lot of problem, right? That's why it doesn't work. Okay. On the other hand, if you do these two, right, if you assign S to the new circle object and you do S.draw, right, would draw work? Would it cause any inconsistency? No, right? Because draw, let's say like if you actually do invoke draw on the circle object, then you can, right? If you invoke on the superclass object, you still can do it, right? Both superclass and subclass always have draw, right? So that's why it doesn't have inconsistency here. Okay. Same thing for this line, right? You do erase on triangle object, you can, because both shape and triangle have erase method, right? So there will be no inconsistency. But here, there would be inconsistency here, right? Because getArea might be specific to the circle, right? But when you invoke it, right, you invoke it on the actual object shape, which might not have getArea. Okay. Okay. Before I want to move on, you guys understand this concept so far, right? If you expect variable to be the superclass, you can assign that variable with the subclass object, no problem. right? Not the other way around, right? If you expect the variable to be subclass, you cannot assign the subclass variable to the superclass object. For this, right, to work, we need to do something called casting. You guys learned casting before in the first 5 weeks? When you want to cast into double, you do parentheses double, right? You cast, technically you can cast some type from one type to another, right? But there's some rules, right? You cannot cast any type to any type, right? You cannot cast string to int, for example, right? You can cast int to double, int to float, right? Maybe boolean to int, right? This is exactly the same thing, right? So if you do this, if you create two objects, one object shape S equal to new circle, the type on two sides are different, right? The left-hand side is a shape, the right-hand side is circle, but circle is a subclass, so that's why you can use it in the superclass variable. But behind the hood, right, they upcast it. What they do that is to cast from type circle to shape. Okay, Java will cast the type, will change the type from circle to shape, right? So basically, it will change the type from the subclass to the superclass, right? This is called upcasting. You cast up in the inheritance inheritance diagram, right? You cast from the subclass, which is at the below of the diagram, to the superclass, which is at the above the diagram, right? You upcast it. Okay. When you upcast, it will be as if it becomes the upcasted type. So in this case, when you upcast from circle to shape S, right, you will lose the access to the circle specific method or attributes. It will become a shape object now. It will be as if a shape object, which means that you cannot access any circle specific methods or attribute anymore. Okay, make sense? What about this? If you do S equals to T, T is a triangle object, right? Then you upcast from triangle to shape, right? And from there, you lose all the access to the triangle specific method or attributes. Okay. Subtype polymorphism allows you to assign the subclass object to the superclass variable. But when you do that, it triggers upcasting, right? Once you upcast from subtype object to the superclass object, you lose all the access of the subclass method and attributes. It will become as if it is a superclass. Good. What about, you can also use polymorphism in the input argument as well. It follows the same rule, same logic, right? For example, if I create a class called canvas, which has one method, right? Draw then erase, that takes the input argument to be shape, right? S. Inside that method, I do s.draw, s.erase, right? Simple method. And what if I write a test application like this? I create a new canvas object. I create a shape object. I do canvas.draw, then erase S. Would it work? Number one, would it work according to subtype polymorphism? It works. Number one, will it cause any error? Do you supply the correct type to the input argument? Right? You supply type shape, right? And expect type shape as well for the input argument. So it works, no problem. What about if you do S equals new circle? You create a new circle object and put the reference to this object to S. And you trigger the same thing again. S a canvas to draw, then erase S. This one works, right, from the subtype polymorphism, right? This line, it works from subtype polymorphism. What about this one? Number 2. Does it work? Right? Because once you upcast, you kind of, it becomes a new superclass object, right? It will be as if it is a superclass object. And here, you expect shape, right? And you supply shape. That's good. What about this one? You create a new circle object. And you do the same thing on C. Does it work? No. In here, you supply circle type, right? But what do you expect from the input argument? Shape type. You expect superclass. Can you put subclass object there? Isn't that what subtype polymorphism means? If you expect superclass, then you can put the subclass object there, isn't it? Wherever the superclass is expected, you can replace it with the subclass object, right? Here, you expect the superclass type, right? Can you put the subclass type here? What does subtype polymorphism mean? Go back to the definition again, right? You should allow subclasses to be used where the superclass is expected, right? If you expect superclass to be used here, then you should be able to use the subclass object as well, right? Because the subclass is a superclass, right? Employee is a person, right? Circle is a shape, right? So in here, you expect the input to be shape, right? The superclass. Then you can supply the subclass object here. No problem. It should work. Okay, good. What about I change to this? I change from shape to circle. And you tell me which line works, which line don't work. Does line number 1 work? No. Why? It expects circle, but you supply shape. Can you use the shape when you expect circle? Because shape is a superclass, right? You cannot use superclass where the subclass is expected, right? It's only one way, not the other way. What about 2? S will hold the reference to the circle object, right? And you put it there. Number 2. Yes. So you expect the input to be circle, but you put shape object there, isn't it? If again, right, when you assign, you put the reference of the circle object to S, right? So technically you upcast it. It becomes a shape object now, right? It doesn't become the circle object anymore, right? Right? So become a shape object now. So you cannot put shape object into the input here, right? Okay. Again, right? Once you upcast, you kind of lose access to everything. That's a catch on that. We will come back to that later. But you can think of it, you lose access to everything, right? It becomes as the superclass object. What about the last one? Yeah, not even subtype polymorphism, but it's just simple input arguments. What about arrays? What if I change draw then erase from just a single object? Here I make an array of the shapes, right? And I just do draw and erase for each of the shape object there, right? And for the test, I create usually I create canvas object. I create a shape object. I create a circle object. I create a triangle object, but point it into the shape variable, right? Then I create an array of shapes here. Does this line work? Does it work? Huh? You want the shapes variable to hold the reference to shape array, right? So basically, each element in the array should be of type shape, right? You expect every element in the array to be a shape object. Can you do this? Yes, no? Yes? No? If no, which one doesn't work? Circle? But you expect each element to be shape object, right? Isn't by subtype polymorphism would make this work? But you expect shape to superclass, so you can use a subclass object instead, right? Technically, it should work, right? In here, S would work because S is shape, right? T would work, T is also shape after you upcast it. C is a circle, but you expect every element to be of type shape, right? So circle would work too, right? Wherever you expect the superclass to be used, you can use subclass object instead. Okay. So what you do this, you can do normally, right? What about this one? The difference is the canvas class is the same, but I create a 3 circle object instead, and I put it into the circle array, and I pass the circle array here as an input argument. Does it work? Obviously, this C1, C2, C3 should work, right? It's just constructors. What about this line? When you declare an array of circles, it works just like you declare an array of objects, right? What about this one? The last line. Would it work? Yes? Yes, no? Why yes? Why no? But don't you expect the input to be shape array? You expect it to be shape array, but can you pass circle array instead? Can you? Yes, right? Because you expect the input to be shape array, right? Which means that every element in the array must be of type shape, right? By having a circle array, it guarantees that every element in the array will be of type circle. So it works, right? Circle is a shape, right? This one would work too. Okay. Again, right? When you visualizing the array, right? You should visualize it for each object inside the array, right? The rule still applies there, right? So if you expect every object, every element in the array to be of superclass, then you can have every element in here to be the subclass here as well. It works, right? That's the single rule, right? If you expect something to be superclass, you can just put subclass there. What about this? It doesn't work. Which line fails? Which line? This line would work for sure, right? This line works, I suppose. This one, do you upcast? You upcast it, right? From circle subclass to the shape, right? What about this one? Require upcasting? Yeah, upcast from triangle to shape. This one, does it work? You create a shapes array that is each element should be of circle type, right? You can you put S in there? No, like it's a superclass. Superclass is a subclass. So you cannot put S in there. Can you put C in there? C is a circle object, but you already upcast it to shape. So it doesn't work too. Morality, our question doesn't work, right? For sure. So this line will fail, okay? What is this? Can I do this? Last one. This one doesn't work. The difference is I create new circle objects, right? I put this C1, C2, C3 into the shape array, but the input argument needs to be circle array. Which one would fail? Which line would fail if it doesn't work? This one would work for sure, right? These 4 lines would work for sure. What about this line? Work? Yes. You declare shapes, a shape array, right? Can you put a subclass object inside the shape array? Right, so it would work, right? Yeah, definitely. What about this one? Why not? It's like yeah, you expect the array of the subclass, right? But you supply the superclass array, doesn't work, right? You can supply the subclass of the subclass, that would work, but not the superclass, right? Got it? It's going to get more confusing from now on. If you don't get it, you have to say it now. Question before we move on. This is the part where, at least for me in the beginning, where this is super confusing. If you haven't followed until now, it's going to get harder. What if I have this code, shape S, and you assign the S with the reference to the circle object, right? You upcast it, right? And if I do S.draw, and I assume that all the subclasses override all the draw and erase method, okay? Circle overrides draw, but is it? Yeah, override, not override. Circle override draw, circle override erase, and so on and so forth, right? The question is, when I do S.draw, which draw method will be called? Which draw method? Superclass? Shape? Any other? Why? Because you upcast it, it looks like it will become the superclass object, right? This is where the confusion starts. The answer is it will go into the actual object. So even if it looks like it becomes a superclass object, but the real object there is still a subclass object. So the checks, right? The check before is done. You can have to think of upcast to be a new superclass object, but the actual method, once the check passed, right, and you call the method or attributes, you have to think of it as if it's the real object, not a superclass object anymore. Okay, you only visualize upcast, right, to be the superclass object for checking, right, whether it's valid or not. But once it passed validity test, and when you want to call the method on this object, you call on the actual object, not the superclass object anymore. So in here, it's the draw. We will call draw method on circle object. Does it make sense? Let's do more exercise. Actually, we'll do more exercise later. So we call this thing late binding because we don't want to bind the method to the actual object right now by looking at the code, right? You want to bind the method when you execute the code. You will know which method will be called only when you execute the code. In some case, you don't even know which method you will be called just looking by the code. For example, what if I create this method called myMeth that takes input argument I, right? I declare a shape variable s, and depending on the I value, I may assign s to a circle or a triangle. And we'll figure out which draw will be called on this s. Not shape superclass, right? Definitely not shape superclass. That's our question, right? It will be called on the actual object, not the superclass object anymore. Would it be called on circle or triangle draw? Depends on I. So looking at the code, you don't know, right? If I give you the code, this code, there's no way to tell which draw will be called, right? Until you run it. You run this method with the concrete input of I, right? If I supply the actual input of I, then I would know, right? If I give I to be 0, you will know that it will be called on circle object, right? And so on. So again, this is the concept called late binding. Basically, it means that the method overriding, right? When you do method overriding, it can be polymorphic. It can have different behaviors depending on the context, right? In this case, it depends on I. Okay, so basically, you don't know for sure sometimes. Okay, and this one, Java will do it for you, right? Java will choose the right class of S when executing draw, right? Only this method of this draw method will be chosen at runtime. You guys know when I say runtime? Runtime, time that you run when you run the program. Yeah. There's another thing, it's called compile time. When you convert the code, when you compile the code into something that machine can understand, right? At compile time, this one, you don't know which draw to be called, right? But at runtime, you can determine it. I mean, Java will determine it for you. Right. So for summary, upcasting, remember upcasting? So if you expect superclass, you can put the subclass object there, right? Once you do that, you upcast it, right? It will be treated as if it's become a superclass object, right? Which means you lose all the subclass specific method at all. You cannot access subclass specific method, right? But then when you invoke the overriding method there, you will not invoke the superclass method, right? You will invoke a subclass overridden method. Okay. 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 Let's do some exercise and then I'll let you do the lab. So the key idea here is it looks confusing. And the worst part is we're not done yet. We will come back to this concept after I introduce you another one called abstraction. We will come back to this to make it more confusing to you. But let's look at this exercise, right? Oh, by the way, this is a different way to draw a UML diagram. This is the way, basically the same boxes, right? Each box represents a class, and you have the arrow for inheritance relationship, right? But in here, the difference is you can have the attribute that looks like this with some prefix here, right? Hashtag plus or minus. Basically, hashtag means protected, Class means public, minus means private. Okay, the rest is the same, right? Method names, attribute name, and so on. And what will be different is override. I introduce override to the method. It means that this subclass will override the set first name of the superclass method. Okay. See the override? Override here, right? When I do override here, it means that parent subclass override the superclass, the person superclass set first name method. Okay. Make sense? I give you the test application here. I want you to tell me whether each line works. If it doesn't work, why? And for the method that you called, which method will be executed? Would it be the person, parent, or child? Number one, what do you think? I create a person per variable, right? And assign per to the child object. Okay, does it work? Because of subtype polymorphism, right? Person is a superclass of the child class. So you can assign a child object when the superclass object is expected. Good. If I do per dot set first name, what happens? Does it work? It works. Which set first name will be called? Person. But is per child, right? Even though you upcast it here, right? You see that child override set first name method, right? So even though you already upcast it to the person class, person object, right? But the actual object is child class, right? So it will invoke it on the child method. What about this? Person G equals per dot get guardian. Does it work? I want to hear from this side too. It works. Why? When you do get guardian, what kind of type do you get? What's the type of get guardian? How do you answer? Person. So does this work? Does it use the subtype polymorphism concept? Does it? Is it person? This is also person. Does it use subtype polymorphism? Subtype polymorphism relates to the concept where you can use the subclass object where the superclass object is expected, right? So it has to have subclass and superclass. Here are the subclass and superclass in here. Person and person. Which one is which one is a subclass? Both of them are persons. There's no subclass and superclass here. No? Right? So it works, but it doesn't use the subtype polymorphism concept, right? It just uses normal concept. What about this one, number 5? Parents. Power 1 equals to new person object. Does it work? Does it work? Why not? Person is superclass, right? So you kind of put a superclass object where the subclass is expected. That is not subtype polymorphism. What about this one? Parent, part 2 equals new child object. Does it work? Does it work? it work? This one. No? Why not? First of all, does parent and child have subclass, superclass relationship or not? Which one is a superclass, different from subclass? No, I mean here, parent and child, right? That's what you do here. Does it have subclass, superclass relationship? It has? Maybe no, right? Parent and child, they don't have subclass and superclass relationship, right? They are the subclass of person, but child is not a superclass of parents, nor the parent is superclass of child, right? So does it work? But it's not because of subtype polymorphism, right? It's because there are two totally different classes, right? You cannot assign two completely different classes into another, right? Into one another. Where did the guy go? Han? Is it what he said? Han. Okay, นานมากนะ What about this one? Parent, part 3 equals new parent. It works. Does it use subtype polymorphism concept? Does it use inheritance concept? Just a normal type assignment, right? It's the same. Both sides have the same type. So yeah. This one, child C equals part 3 dot get child. Does it work? No, it doesn't work. Why not? That's not really easy. What is the return type of get child? Huh? Child. Do you expect child object on the left hand side? Yeah, you expect child object, right? You will also return type child. Does it work? Yeah, you return child object, and the left hand side you expect child object. Why not, right? It's the same type, exactly same type. Which get child will be called this one, right? I mean, that's the only one there to begin with, right? What about this one? Number 9. Number 9. Number 9, does it work? Number 9. Does it work? Does it use subtype polymorphism? Which one is the superclass with the subclass? Also the superclass, and what is subclass? Yeah. Child, right? You return get child, is the type child, right? So you return subtype object and we put it where the superclass is expected, right? So it works. Which I already asked. What about this one? Person per 3 equals C dot get guardian, where C is a child. Does it work? It works, right? When you do C dot get guardian, right? C is child object, right? So you see there's a get guardian there, right? Which return person. You assign into the person. So yeah, just a simple type assignment. No inheritance, no polymorphism, right? Last one. Last one. Does it work? Yes. Other people? Other people? Does it work? That works? Everyone agrees that it works? Last one? Does it work? Last one. Number 11. No? You the other want to say no? No too? Yes? Yes? No? Yes? No? But why no? Which one fails? If no, something must break, right? Which one breaks? Huh? Spur two? So, sorry? Spur two don't get guardian? Don't have guardian? So Spur two cannot access get guardian? No? This means you don't agree, or it always no, it means it's correct? Oh, parents don't have get guardian? But yeah, per two is a person type, right? When you guys say yes, why? When you say yes, why? No? Are you sure? Per two has no access to get guardian, but you upcast it from child, right? Don't you access? Don't you also have access to get guardian? When you already upcast it, the actual object is child. Child has get guardian, right? Isn't it? Child has get guardian. You upcast it to this guy. Can't you access get guardian? You can. Yeah, now you understand why it's confusing, right? What's the answer? Can you guys agree on something? One line of thought saying that, oh, per two is person type, right? Person doesn't have get guardian, right? Another line of thought is that per two actually try to child objects, and this one works by upcasting it, right? So technically, per two is actually get child object, right? So child object should have access to get guardian, right? Which one is right? Which one is correct? Recall the polymorphism. Let us go back to polymorphism. What happened when you upcast? And what else? You lose all subclass specific methods. Whatever methods that are specific to subclass that superclass don't have, you cannot access it anymore. You cannot access the same thing for attribute as well. Right? What about this one? Late binding. For overriding method, right? Java will select the correct overriding method at runtime on the actual object, not on the superclass, right? Specifically on the overriding method only, right? It doesn't say anything about non-overriding method, right? So what's the answer on this? No, it doesn't work. Which one doesn't work? Get guardian to next is going to be new. Right? You use the concept of upcasting, right? Once you upcast from subclass to superclass object, you lose all the access to the class-specific attributes and methods. Get guardian is specific to child subclass, right? Once you upcast it from line number 9, right? Sorry, it's line number 9. Yeah, from child to person. Technically, you should treat person per2 as a person object. It should lose all the access to all the class-specific attributes, all child-specific attributes and methods, right? So this is why you cannot do per2.get guardian, right? Even though per2 is actually a child object, right? You cannot do it. Okay? Make sense? You guys. Last one, one more exercise. What if I have 4 classes here? Person, student, undergrad student, and freshman, right? Person has name attribute, has get name method. Student has set name method, override get name method. Undergrad student override set name, and freshman overrides get name. Okay, I have these test cases here. What happens on this thing? Let's start one at a time. One line, right? Person per equal new student. Does it work? Does it work? Yes, no? Okay, right? Does it use subtype polymorphism? Yeah, right? Yeah. Because student is a subclass of person. What about if you do per or set name? Which set name will be called? Person, student, undergrad student, freshman, student. First of all, does it work? Does it work? Does it compile? Per or set name? Set name has what? Does it work? Same thing, right? Same concept as previously, right? Once you upcast from student to person, you lose access to class specific method, right? You lose set name here. Set name is specific to student that person doesn't have, right? So here it would fail. What about this one? Does it work? Can I do per equals new undergrad student? Yes. Yeah. Does this use subtype polymorphism concept? So undergrad student is subclass of person. Is it true? Okay, right. Even though it's 2 classes below, right? Still the class below is still a subclass of a superclass. Right? If I do per.get name, which get name will be called? Person get name. This one. Is that right? There are 3 get names, right? This one. Person get name, student get name, freshman get name. Which one? Huh? Person class get name? Do you agree? Person. What about people in the back? Do you use person? Which one? Student? Undergrad? Undergrad student? Student? Normal student? Student? So get name is overriding method, right? You override get name in student here. So when you invoke on per, right, which for reference to undergrad student, right? If you try to invoke get name that belongs to undergrad student, does undergrad student override get name? Then do I go person? Do I go to student next? Which one? Right, you go one class up at a time. You don't go to the topmost, right? You go one class up to see student and see that get name is there. So you use this one. Okay. It's like student S equals to a new freshman. Does it work? It works. Subtype polymorphism. Subtype polymorphism, right? Freshman is a subclass of student superclass. If I do S plus set name Mike, does it work? Yes, it works. Which set name is called? Student. Is that right? Okay. Right. So it will try to call on the actual freshman object. No? Isn't it? Use. So in here, you already upcasted, right? But you try to call overriding method here, set name. So it will try to call this method on the actual object, right? Freshman object. Does freshman have set name? It will go up. Does undergrad have set name? So it will call on undergrad, right? Not on the student. Okay. What if I do s of get name? This one. Okay. You guys okay on this cluster X? Understand? You guys, when I say this, right, this is the when I ask you as a quiz like this, right? This is something that you have to justify, right? Like because of this, and that. Okay. What about this one? S equals per. Does it work? No, no, right? Because you're trying to assign the superclass to a subclass object. Okay. So this one definitely wouldn't work because the slide doesn't work. What about this one? S equals new undergrad student. It works. This is use subtype polymorphism. Which one is a subclass? Superclass is student. Okay. Set name, which one is called? Undergrad student. Okay. Get name. Student. Okay, good. Great. You're ready for lab 3. This one. So you have to consider left hand side and right hand side. What's the type of per on the right hand side? It's a person, right? What about the left hand side? Left hand side. What's the type? Student. Can you assign a person object to a student variable? Okay, that's why it's failed. Okay, right. So I could do S equals, oh, no, actually I can't have. Sorry. Who is a person? Okay. Okay, great. Then let's take a look at lab 3 now. We start recording.